So let's see another problem in classical mechanics. So a sphere of mass capital M and radius r small r having a translational velocity v naught and angular velocity omega naught such that v naught is greater than omega naught or is placed on a rough surface with mu as the coefficient of friction. Slipping takes place for some time. So out of the question, so whether we have to, so this is the question. So according to the question, a sphere of mass capital M and radius small r having a translational velocity v naught. So the sphere is having translational velocity. That means because of which the sphere moves from one point to another point in a particular direction. So this is the uh, imaginable diagram. So this is the sphere, so it is moving in this direction. That is, if it is moving from one place to another place, that is nothing but translational motion. And the translational velocity is v naught, they are saying translational velocity v naught. And angular velocity means the speed with which the sphere is rotating. So it is rotating, the sphere is rotating, so that is it is rotating with the speed omega naught, angular velocity. And is also it is given in the condition given is v naught is greater than omega naught, or it is saying, so if v naught is greater than omega, v is nothing but r omega. Actually what does this means r omega naught is nothing but displacement occurring in a given time because of rotational motion. So actually the sphere is rotating here, so because of rotating it is moving forward. So if it is moving forward only because of rotation, then we would have v naught is equals to r omega naught. So that also we'll see. So but here it is given that v naught is greater than r omega naught. So then in that case what happens is it moves extra distance another than rolling distance, that is because of slipping of the sphere. So that is the condition, v naught is greater than r omega naught, and is placed on a rough surface with mu as the coefficient of friction. So this rotating sphere is suddenly placed on the rough surface and its coefficient of friction is mu, they are given. Slipping takes place for some time, so it is given that slipping of the sphere would take place for some time. That means not pure rolling motion, but slipping also would take place for some time. That one they are saying. So now we need to see whether which of the following options are correct. So multiple options answers. So first option is pure rolling states after a time, that is starts, actually that is starts after a time 2 by 7 v naught into v naught minus r omega naught by mu g. We have to find this whether it is true or not, and the translational velocity with which it rolls is 5 by 7 into v naught plus omega naught r. So that also we need to find out. And this thing, see, if v naught is equals to r omega naught, then there would be no slipping if pure rolling would commence immediately. So now only we have discussed. So if there is only pure rolling, the sphere would move in this direction because of this rolling motion. So how much distance it has rolled, how much circumference this sphere has rolled, so that much forward it would move. So how much angle it has rotated, and the angle length of the arc for that particular angle, so that much distance it would move forward in this linear direction, translational motion. So hence it is this option is correct. So here answers are a comma c. So if v naught is equals to r omega naught, then there would be no slipping, there would be pure rolling motion of the sphere. So that is correct. And we need to see another whether out of these four options which are the true. Since friction is dissipative, we cannot apply the conservation of angular momentum. So these are the four options. So we need to find out which options are correct for this question. So here options answer is a comma c. So how it is a comma c, we'll see now. So we just do solve this problem. So since v naught is greater than r omega naught, the sphere slips forward, so the friction at the point of contact acts in the backward direction. So this is the important point. So this was given in the question. V naught is greater than r omega naught. So if this is the case, what happens is the sphere would not roll. Of course it would roll, but in addition to rolling, there would be slipping of the sphere. It just skids. The sphere skids on the floor, and also it rotates. So the sphere slips forward, so that means it moves in this direction, in the forward direction. So if the sphere is moving in forward direction, if it is slipping in the forward direction, then at the point of contact, friction would act in the backward direction. So friction would always act in the opposite direction of motion. So here, because of slipping, friction is developed initially. So what we are doing here is we are taking a sphere which is rotating with the angular velocity omega naught. We are just suddenly, and if it has a nearly translational velocity v naught, if we place it on the floor, we will know it. So suddenly this rotating sphere is placed on the rough surface. So at that time, what would happen is the sphere would first slip, and it would roll as well as it would slip, and after some time it would catch a pure rolling motion. It would just keep on rolling, but it would not slip, so for a certain period of time. So when the process of slipping, friction is developed. So as the sphere is moving in this direction, sphere friction acts in opposite direction. So this is the free body diagram of the sphere. So the sphere is moving in this direction, so as it is given in the question, translational velocity v naught, and it is rotating omega naught. So it is rotating like this, and it is moving forward direction. So it is rotating, and it is moving in this direction, and it is slipping also in this direction. So frictional force would be in opposite direction. So it would, as the frictional force is a contact force, that is the thing we need to important point. So we cannot draw this frictional force at this point in this direction like that. So actually this v naught is the velocity of this center of mass point. So that's why we have given like that. And here this frictional force is a contact force. It acts at the point of contact. So here at the point of contact, from the point of contact, this is the direction of frictional force. And also weight of the sphere would be acting vertically downwards. So that is mg. So actually in the question it is given a capital M, but here it is taken as small m. So nothing wrong. So weight of the sphere acts vertically downwards, and because of that weight, this is action, and as a reaction, normal force would act in the opposite direction, that is in this direction. So normal force is also a contact force. So for every action there is equal and opposite reaction like that. So because of weight acting downwards, contact force develops. So it would act in the upward direction, that is normal force. So this is the free body diagram of the sphere. And next thing is for translational motion, F is equals to minus ma. So force acting on the sphere for translational motion is minus ma, mass into acceleration. Actually here retardation is taking place. Why means this frictional force would slow down the sphere, would oppose the motion of the sphere. So that is the thing. So F is nothing but frictional force here. So F is equals to minus ma. Because of this frictional force, retardation is developed. Acceleration acts on the sphere because of this frictional force only, as it opposes the motion of the sphere. So F is also minus ma. This is the force acting on the sphere. So where a is the linear acceleration, and this is for translational motion, we would have linear acceleration. And for rotational motion, so if we consider the case of rotational motion, so in that case torque would act. So in linear motion, if in linear motion force acts on the body, in rotational motion torque acts on the object. So we know that torque is nothing but r cross f. So if we see from the diagram, so about the center of mass point, if we see, so this is r position vector, and this is f. Both of them are perpendicular to each other, r cross f, that is nothing but rf sin theta. So rf sin theta. Theta is 90 degrees. Angle between R and F is 90 degrees. So you would have RF, R cross F. And another formula for torque is nothing but I alpha. Just we have F is equals to ma. We have torque is equals to, in the place of m, moment of inertia I, and in the place of linear acceleration, angular acceleration. So I alpha. So, and we know that moment of inertia of the sphere, as this is a sphere, solid sphere, so 2 by 5 mr square. I is nothing but 2 by 5 m r square alpha. So this is the case for rotational motion, and alpha is the angular acceleration. We may note that a is not equal to r alpha because pure rolling has not yet commenced, but slipping takes place. Yes, of course, just like v naught is not equal, v naught is greater than r omega naught initially, that means v naught is not equal to r omega naught. In the same manner, a is not equal to r alpha. So if there is no pure rolling motion, if the sphere is slipping, so we cannot have a is not equal to alpha r. Acceleration comes out because of the slipping as well as rotational motion of the sphere, because of them both. Hence a is not equal to r alpha. So pure rolling has not yet commenced, but slipping takes place, and F is equals to mu mg acts on the sphere. So what acts on the sphere is frictional force. Frictional force, formula for frictional force is nothing but mu n, coefficient of friction into normal force, and we know from the diagram normal force is nothing but mg, that is n is balanced with mg is equals to n. So hence we are having F is equals to mu mg. Now as normal force is equals to weight of the sphere, so frictional force mu s n, so mu mg acts on the sphere. So in the place of F, we are replacing it with mu mg. So here if we cancel out m, and we need to find alpha. So m or also if we cancel m or, so send this 5 to that side. So we would have 5 mu g by 2r, 5 mu g by 2r. m1 has cancelled, so 5 mu g would remain, so 5 mu g, and here also m1 has cancelled, only 2r would remain by 2r. So alpha is nothing but 5 mu g by 2r, and a is minus mu g. Why means, as we know that F is equals to mu mg. If we substitute in this formula, mu mg, would get cancelled, and a is nothing but minus mu g. So from this formula, a is minus mu g. So integrating the acceleration to get velocity. So now what we have to do is integrating this equation. Alpha is nothing but d omega by dt. So as we know, just like acceleration is dv by dt, in the same manner, alpha is nothing but d omega by dt. So if we send this dt to that side, alpha is nothing but d omega by dt. If we send this dt that side, and if we do integration on both sides, what would happen is integration of d omega. Integration from omega naught to omega. Limits are from omega to omega naught. So integration of d omega is nothing but just like integration of dx is nothing but x. So we would have omega, and limits from omega naught to omega. So omega minus omega naught, omega minus omega naught. That omega naught we are sending to that side, and here if we do integration with respect to dt, so here 5 by 2 numbers constant, mu coefficient of friction also constant, radius of the sphere also constant, acceleration due to gravity is also constant. So we would have simple integration of dt from 0 to t, that is nothing but t, and applying limit 0 to t minus 0. Hence we are having this. So 5 by 2 mu by r g t, and omega minus omega naught, sending this omega naught to that side, we would have this. So if we simplify this equation, that is if we do integration on both sides of this equation, we will get this equation. In the same manner, this equation also. So as we know that a is nothing but dv by dt, so dv by dt, sending dt that side. So integration of dv is nothing but v, upper limit minus lower limit, that is v minus v naught. So final velocity minus initial velocity, so v minus v naught, sending that v naught to that side, and here minus mu g dt would be present. So integration of dt is nothing but t minus 0, so minus mu g t plus v naught. So just all this we have got from this integration of these two equations. These two equations could be obtained by integrating them. And next thing is, pure rolling starts when v is equals to r omega. So when v is equals to r omega, in that case pure rolling motion would start. V is also r omega. Y means initially the velocity of the sphere was v naught. So as it moves down, it just retardation acts, so it just slows down. So as time passes by, v would be the at some particular point v would be the velocity of the sphere, and its rotational speed also would be affected. So initially it was omega naught. So because of frictional force opposing, its rotational speed also would have been reduced. So omega. So v is the velocity at particular time, and that is translational velocity at particular time, and omega is rotational velocity at some particular time. So when pure rolling starts when v is equals to r omega. So when v is equals to r omega, then only rolling motion would be there without slipping. So entire velocity of the sphere, that means the sphere moves forward only because of rolling. Sphere is moving forward because of rolling only. So when v is equals to r omega, rolling starts. So now what we have to do is, so in this equation, minus mu gt plus v naught is there. In the place of v, we need to substitute r omega. So as we know omega, this is omega. So this based on this equation, so minus mu gt plus v naught, minus mu gt plus v naught. So in the place of v, r omega. Omega is this. So this one multiplied with r. This entire equation multiplied with r. So if we multiply this entire equation with r, so r would get cancelled. So 5 mu gt by 2 we would have, and r omega naught from these two equations solvation. So and next thing is simplifying this. So v naught, and sending this omega naught r to this side. So v naught minus omega naught r, and sending this all the t terms to one side. So here t term is there, sending it to this side. So if we take t common, we would have 5 mu g by 2 plus mu g into t. So after sending this v naught minus omega naught this side and this one to that side, simplification and taking t common, we would have this term into t. So we want only t. So sending this t into that term to that side, so it would divide. So we would have t is equals to v naught minus r omega naught divided by 5 mu g by 2 plus mu g. So that is the thing. And next we need to do simplification. So if we take LCM here, so 5 here, 2 is the LCM, so 2 into 2, so 5 plus 2, 5 mu g plus 2 mu g, that is 7 mu g by 2. So 7 mu g divided by 2, sending the 2 to that side. So we would have this, and so from this we have proved this point. So pure rolling starts after a time, actually it is starts after a time 2 by 7 into v naught minus r omega naught by mu g. So here also we have 2 by 7 v naught minus r omega naught by mu g. So option A is correct, and option C is also correct as we have discussed. And next, wait a minute. So next thing is we need to find translational velocity with which it rolls. That is the thing we needed to find out. Next point. So let's see. So v is nothing but translational velocity here. So we have the equation for translational velocity, v naught minus mu gt. So v naught, keep it like that, minus mu g. In the place of t, we need to substitute with this. So 2 by 7 v naught minus r omega naught by mu g. So that is the thing. So mu g would get cancelled. So 7 v naught, sending the 7 v naught minus 2 v naught, minus into 2 v naught minus 2 v naught. That is a minus 2 if we keep aside. So v naught minus r omega naught, if we solve this, 7 v naught minus 2 v naught is nothing but 5 v naught, and minus into minus is plus 2 r omega naught by 7. So this is the thing. So v is nothing but translational velocity, but here it is given 5 by 7 common, v naught plus r omega naught, but here we are having 5 v naught plus 2 r omega naught by 7. Hence this is not possible. B is not the answer options, and C is also true, because v naught is, when v naught is also r omega naught, so there will be pure rolling motion as we have discussed earlier. And finally, so only A and C are correct, and D is also wrong. Why means, so since the friction is dissipative, we cannot apply the conservation of angular momentum. So that is also a mistake. Why means, the conservation of angular momentum depends on the existence of external torque on the system and not on whether the forces are dissipative or not. So conservation of angular momentum, it does not depend on whether which kind of force is acting, whether it is conservative force or non conservative force. It only depends on whether the external torque is acting on the system. If the external torque acting on the system is zero, then angular momentum would automatically be conserved. Why means we know that tau is equals to dl by dt, just like f is equals to dp by dt. Like that we have a torque tau is equals to dl by dt. So if the external torque acting on the object is zero, then angular momentum would remain constant, because differentiation of constant is zero. So that is the thing we are saying here. And so here this point is also a mistake. So frictional force is acting, we cannot apply conservation of angular momentum, they are saying. So we cannot apply conservation of angular momentum saying, but we can apply, because the torque acting on this is zero. So here it is given. So in fact, if P is the initial point of contact, about P there is no external torque on the sphere, the weight and normal force. So the angular momentum of the sphere about A is conserved. So at the point of contact they are saying there is no external torque, they are saying. So this is the point of contact. So there is no external torque. By means at this point what are all the forces acting? So weight is acting vertically downwards and normal force is acting. So that one they are saying. But torque is nothing but R cross F. So R is in this direction and F is also in this direction. That means both of them are parallel and anti-parallel, like that. That is theta angle between R and F is 0 degrees here. So R is in this direction. If you consider angle between R and MG is 0. So R cross F means RF sin theta. Sin 0 is 0. Hence there is no torque acting. Even if you consider normal force, it is acting in opposite direction pi. No, it is acting opposite direction pi. So R cross F theta is nothing but pi. That is 180 degrees. Sin pi is 0. So hence we won't have external torque acting on it. So as the external torque is not acting, angular momentum is conserved. So only the answers for correct options for this question is A and C. So that is the problem. So thank you.